Here we go. For our warm-up, we're talking mostly about square roots. And for our warm-up today, you have to find two whole numbers that each of the following is in between. So if you notice, for square root of 7, for this first group, they put square root of 7 is between 2 and 3. Why? How do we know that the square root of 7 is between 2 and 3?
2 times 2 is 4 and 2 squared is 9.
Beautiful, because 2 squared is 4 and 3 squared is 9, right? And 7 is in between 4 and 9. So, all right. Gentlemen in the back, can you write down, please? All right. So square root of 19, well, that would be between the square root of 16 and the square root of 25, somewhere between 4 and 5. Does that make sense? Did it work? See? Aren't they nice? Okay. All right. Square root of 43 would be, you got to think of perfect squares, right? So it would be somewhere between 36 and 49. So the square root of 43 is between 6 and 7. All right. When x squared is 98, well, 98 is between 81 and 100. So the square root of 98 would be between 9 and 10. What about the square root of negative 68?
Can't.
Yeah, it can't be done. It's an imaginary number. It's not a real number, and therefore, as long as we're in real number world, which we are right now, there is no solution to that. Yeah. All right. Okay, so today we're doing section 3.6. We're focusing on square roots and reflections. Square roots and reflections. We'll have a little bit of review from yesterday. We're going to learn about square root functions. We're going to learn about reflections. We're going to put the reflections together with translations. And we're also going to do a little step into odd, even, and neither functions today. All right, so section 3.6, reflections and the square root family of functions. I don't remember what kind of functions we learned about yesterday. Quadratic. What's that? I didn't hear what you said. Yeah? Oh, they're easy. Oh, is that what you said? They're easy? Oh, I'm glad you think so. Okay. I'm hoping you think square roots are easy too. Okay, are we all ready? Good to go? No. People still writing the title. Okay. All good? Do I put the phone away? A lot of people coming in. Okay. Thank you. All right. All right. So, y equals square root of x. So yesterday for quadratics, the parent function is y equals x squared. Today for square roots, the parent function is y equals the square root of x. Y equals the square root of x starts at the point 0, 0, and then kind of goes out like this. So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, right? So the square root of x starts at 0, 0, goes out like that. My first question to all of you is, in your groups, I want you to take a second or two, and I want you to find the domain and the range for this function. Take a minute, talk to your group members. I want you to see if you can come up with the domain and the range for the domain. Deal with x values or y values? X values. Domain is all the x values where the graph exists, right? Where the function exists. So what is the smallest x value where this function exists? 0. 0. Does the 0 get included or not included? Included. Yes, it gets included. If there's a dot there, you include the 0. What's the highest x value for this function? Infinity. It's never going to end. Do we include infinity? Never. Never include infinity. It's not even a number. You can't include it. All right. Range. Range is y values. What's the lowest y value on this graph? 0. What's the highest y value on this graph? Are you sure? Yeah. It will eventually, it grows really slow, but it will eventually get to infinity. You just have to go really far. All right. Of course, what is infinity, right?
I have a question.
Okay. Yes.
So when you know how you write like the domain 0
The left is set notation. So if you wrote it like this, 0,
range for y.
and then this would be 0 less than or equal to y. Yes, very good question. No, these you don't. The only thing you could do if you wanted to, for like if you wanted to be really an extra star student, quiet down please. Technically this is not correct. Technically the correct way to write set notation for domain would be to put a brace like that, then to say, hey, x is in the set of real numbers such that 0 is less than or equal to x, which is less than infinity, and then you close the brace around it, right? You identify what set x is an element of, and then you say what's the actual restrictions are on your domain, right? Yeah. So this is the technical correct way to write your domain. But we never, like, no one ever checks that, so. Anyway. But yeah, this is fine or this is fine. All right. So we're going to start by reviewing what we did yesterday. Yesterday we learned translations, but we learned them in the context of y equals x squared. Today we're going to do translations in the context of y equals root x. So root x right here starts at 0, 0, and goes out like that. So we have graphs A, B, and C. I'm going to start you off with graph A. So for graph A, this graph has been shifted how? Right by 3. When we shift left or right, do we add to the input or the output? To the input, right? So for a root function, the input is under the root. So I'm going to have like an x here and a 3 here. When I want to shift to the right, do I add or subtract? You subtract. You do the opposite of what you think. So this would be the square root of x shifted 3 places to the right. If I wanted to shift up or down, I would add or subtract a number out here, outside of the root. Which is why when you're writing answers for me on your quizzes and your tests, where this root symbol goes, that's really important. If you are like a lazy root writer and you don't quite cover the 3, I'm not going to give you credit. So make sure it's really clear that this square root symbol goes over the entire x minus 3. And then if there's a number out here, that it's not under the root. Jay, do you have a question? No? All right, everyone take a minute. Your groups do B and C. Write down, please. So for letter B, write down. B, we are shifted how many in this direction? 5 to the left, and then down 3, right? So we have y equals square root of x, what's going to go in here? Plus 5, so that we have that left shift, and then minus 3 out here. Good. How are we on that? Everyone comfortable with that translation? All right. All right, let's do graph C. Graph C is not shifted left or right. It's just shifted up 5. So the equation for graph C, what would be?
Square root of x.
Square root of x
Outside you add
plus 5. Okay, does everyone understand that? Any questions on translation? All right, good. All right, so now we're going to first talk about reflections in general. So when you are reflecting, and this isn't exactly mathematically correct wording, but that's okay. It's fine to say. You're flipping a graph over a line. So you're kind of like flipping it over a line. You've probably done this if you've ever had a picture and you like flipped it. You have choices like flip horizontal or flip vertical, right? Those are reflections when you flip it over a line. So the thing that's kind of unusual about reflections, they're a lot like left-right transformations or translations in that they do the opposite of what you think. So if we have a reflection over the x-axis, we multiply the y value by a negative. And if we have a reflection over the y-axis, we multiply the x value by a negative. Let's talk about why. So say I start with a point 2, 1. If I multiply the y value by a negative, I end up at 2, negative 1, which just flips that point over the x-axis. When you have a reflection, if you took your axis and like say that was your, like say this is a piece of paper, if you fold the paper along the axis, fold it up, they should land right on top of each other. Right? It should be a mirror image. Okay. All right, so when you multiply the y by negative 1, you reflect over the x-axis. If you multiply the x by negative 1, so say here, instead of 2, 1, we go to negative 2, 1. Now, we have a y-axis reflection. We're flipping over the y-axis. Okay, so they kind of do opposite of what you think. So x-axis reflection, you multiply your y by negative 1. Y-axis reflection, you multiply your x by negative 1. Yes, sir.
What's it like when it's like, so say the parabola is one like this at 2, 1. What is it called when it stays at 2, 1 but it turns down?
Okay. Oh, so you want to know what the name of that is? Okay, so that would be a combination of a translation and a reflection. Every transformation is a combination of a translation, reflection, dilation, or rotation. So, and actually, technically, all rotations can be combinations of translations and reflections. It doesn't have its own name. It's just a combination of a translation and a reflection.
So would it say combine these two?
You'll see. We're going to do some today. Are you excited? Okay. Boone, did you have a question?
Never mind.
All right. Okay, now we're going to start with an example without any functions, no function names given. We're just going to start with this generic graph. And we're going to just see how well we are at reflecting this. What I want you to do on your paper is just sketch a sketch of this graph. It doesn't have to be perfect, right? No one's going to grade it. Just sketch a rough sketch of this graph. And then on your paper, I want you to see if you can sketch what it would look like if you reflected it over the x-axis and what it would look like if you reflected it over the y-axis. So take a minute on your paper, see if you can sketch an x-axis reflection and a y-axis reflection. So my first question, so this blue one, y equals negative f of x, is that going to reflect over the x or the y-axis? X-axis, because we're multiplying the negative by the y value. So when we reflect over the x-axis, if you're having trouble reflecting a whole graph, just reflect some points individually, right? So if this is the point negative 2, 1, when I reflect over the x-axis, I multiply by my y by a negative, so this becomes negative 2, negative 1. And then up here, I have 1, 4, so I'd go to 1, negative 4. Here I'd go to 3, negative 4. And then 4, 6 becomes 4, negative 6. And then just connect the dots. Something like that, right? And then I can always, is a good idea to either, for you guys, you just turn your paper, so turn your paper along the axis so that you can make sure that it looks mirrored image on both sides. All right. The red graph, we're multiplying the x by negative 1, so this is a y-axis reflection, which means all of our x's are going to change sign. So negative 2, 1 becomes 2, 1. 1, 4 becomes negative 1, 4. I've lost it. And we get that. And if you sketch your axis, right, this is our original, this is our reflected, They should make mirror images. It's okay if they cross over each other. All right, any questions on either one of those? You will have to do that on your test, and I've been told that students struggle with that a bit. So if you have any trouble, just come in and talk to me and ask me for help. We'll practice that more, each day as we get closer to your test. So, sketching graphs like generic, we just give you a generic graph and say shift it down or reflect it over this or whatever, right? Anyway. Okay, now we're going to connect square root functions to reflections. First, we're going to start simple. So the square root function, the parent function, so here we've got our parent function is in blue, so I'm just going to sketch roughly. So pretend that's a little more tilted, but anyway, that's a rough sketch of the parent function for each of these, right? So there's a parent function for each of those. So your job is to take a moment and see if you can figure out what the new reflected function equation would be. So take a minute in your groups, see if you can write a y equals something for this graph, and then a y equals something for this graph. All right, take a minute. Is this an x-axis reflection or a y-axis reflection? It's an x-axis reflection, which means are we going to multiply the x by -1 or the y by -1? The y by -1. Now remember, when you're writing these equations, if y equals root x and we multiply the y by -1, where does the negative go? Inside or outside? Outside. Okay. For this one, x-axis or y-axis reflection? Y-axis. Good. So now I have to multiply what? The x by -1. So that goes inside.
You can't square root a negative number.
Ooh! Oh, I love that. Okay, quiet down, please. So the question, or not the question, but the comment was you cannot take the square root of a negative number. So our concern is negative x a negative number? Let's take a look. I'm going to erase the parent function, and let's just take a look at our graph here of y equals root negative x. All of these x values, what do they all have in common? They're all negative, right? So if I were to plug in x equals -4 right here, for my x, I would get -4, which is +4. No? Okay. Remember x, so let's say x is -4. Here, I'm going to move this down. So y of -4 would equal square root of negative times -4, which is the square root of 4, which is 2, right? So we're multiplying our x value by -1, which is why all these x values are negative or 0, because that's what makes them positive, so they're okay. That's why we can't have any positives, because then you'd have a negative in here, right? Okay. Good. That was such a good comment. All right. Are there any other questions or observations? We all good with these two? All right. Then I think it's time to put them together. So here is your job. And I want you, I'm going to make a dark circle here so you can see where these start. You can either use Desmos or you can use a graphing calculator, but I want you to see if you can find the equation for each of these graphs. Both of these graphs involve both a translation and a reflection. So your job is to figure out, where does the negative go? Am I going to add or subtract inside of that root? Add or subtract outside of that root? Oh my goodness, what happens? What happens first, right? So I want you to take a minute in your groups and either use Desmos or use your graphing calculator, play around with this and see if you can find the correct function. Maybe take a guess first and then graph it and see if it works, okay? Quiet please. Is the first one a reflection over the x-axis or the y-axis? X-axis. So am I going to multiply by negative by the x or the y? The y. So I have y equals, quiet please, negative square root. Now we got to figure out how to translate. What did you guys come up with?
X minus 2.
X minus 2. But that's just like if we translated it normally without the reflection. Doesn't that reflection move it around somehow?
No, it just
Flips it. Now, why does it just flip it? Does it really just flip it?
yeah.
No. Okay, quiet please. Transformations follow order of operations, just like regular math follows order of operations. So let's think about order of operations. Have you guys ever heard PEMDAS?
Yeah.
Okay. So the P in PEMDAS stands for parentheses, right? But it doesn't just mean parentheses, it means grouping symbols. The square root function is a grouping symbol. It might not look like it is, but it is. So we do what's in here first. So I'm going to start. Here's our parent function, right? There's our y equals root x. So this says take that function and shift it to the right 2. So I'm going to take my root x and shift it to the right 2. So there's my parentheses. Done. Now, next, according to PEMDAS, do I do multiplication next or subtraction next? Multiplication. So this right here, this negative, says reflect over the x-axis. So now I'm here. So I've shifted right 2. I've reflected over the x-axis. And the last thing I do, according to order of operations, is I go down 2, and I end at my final graph.
Wow.
Right? So that's how it works. Now, in essence, what that means to you is when you have an x-axis reflection, you just put a negative in front of the root, and you can just still do your new, like your translations just like normal, right? Which is nice. Now let's talk about a y-axis reflection. A little bit trickier because now the negative goes where? Inside. Now, personally, what I like to do to help me kind of digest these is I like to put my x with the translation in parentheses and keep the negative kind of in front, because if I do that, then I can use my normal translation like I've always done. We have moved this 4 to the left and 3 up. So 4 to the left, what would go in here? X plus 4. And then 3 up out here, plus 3. Now, if you want to write negative x minus 4 in here, that's fine. It just doesn't, for me, my brain wants to look at it and just see the new, like, vertex, the new starting point. Like, I can look at this and say, oh, it's negative 4, 3. So, and there's a reflection, right? So that's how when I do these, that's how my brain looks at them. If you want to distribute the negative, that's fine. That's on you. But for me, this is easier for me, for my brain to digest. But I'm fine either way. All right. So if you're unsure, let's pretend, like, hypothetically, let's just pretend that your test was no calculator. And you're like, oh my gosh, I'm about to take this test. I don't have a calculator. I'm sketching this graph. It's got a translation and a reflection. I don't know if I did it right? Okay, how do I know? Well, we can always plug in this point. This is the point, negative 4, 3, right? What does that mean? That means when x is negative 4, y has to equal 3. So plug in the negative 4. What's negative 4 plus 4? 0, right? We all know that? Okay, so negative 0 is still 0. What's the square root of 0? 0. What's 0 plus 3? 3. So yes, we landed on negative 4, 3. If you're unsure, You could pick another point like -5, 4, because sometimes, like, even if -4, 3 was right, we don't know that maybe it didn't go like that. Whoa, right? So how do we know for sure? Plug in -5, 4. What's -5 plus 4? -1. What's -1? 1. What's the square root of 1? What's 1 plus 3? 4. There we are. So you can always check your graph against your equation by plugging in a point or two. Does that make sense? By the way, if you're starting with the equation and you need the graph, again, I mean, no one can ever stop you from, going back to basics and just plugging in some values for x and getting y's, right? The only problem is with a root function, you got to make sure that you end up with positive. So sometimes you have to play around. Anyway, all right, moving on. All right, now we got to talk a little bit about odd and even functions. We're going to spend a few minutes on this, and then we're going to solve some equations, and then we're going to be done. I am going to show you a couple of methods for odd and even functions. First, I'm going to describe what they are, and then I'm going to show you a shortcut. Got to do the long way first, because the shortcut only works on a very specific type of function, and the long way works for everything. And when you go higher in math, you're going to have to do this on other functions, not just these. So anyway, but we're going to start by just graphing. I'm going to sketch 4 simple graphs here. They're not going to be beautiful. They're just kind of rough graphs. What equation do you think this is? Y equals x squared, right? And it is. Y equals x squared. All right, now I'm going to do, problem, sorry. It went a little wide. I don't want it to be that floppy. It's supposed to just look normal. All right. What equation do you think that is, pretending that it's the same shape as this, just upside down? Y equals negative x squared. All right. This one right here, it looks just like that, but it's not. This one is that, negative x squared. And this last one, which looks just like this one, is not this. It's, I'm going to write up here, negative of negative x squared. So here's my first question to you. Which graph looks just like y equals x squared? Right, y equals the quantity negative x being squared. Because y equals negative x quantity squared is the same thing as y equals x squared, this function is called even. So let me show you. I'm going to write it. Don't write this. I want to give you a better definition for even. Move that over. All right. An even function has y-axis symmetry. An even function is any function with y-axis symmetry. So if you look at this graph right here, this graph, if you look at the y-axis, it divides it into 2 exact mirror images. This graph has y-axis symmetry. That means this function is called even. Now, how do we test for an even function if we don't have a graph? The test to prove something is even is we have to show y equals, or I'm going to show it like this. That's why we write in pencil. Okay, we have to show f of negative x equals f of x. That's for an even function. For an odd function, An odd function has something different. You'd think it has x-axis symmetry, right? Let me ask you really quickly, if you have a function with x-axis symmetry, does that exist? Can that exist? Why not? Because it fails the vertical line test and therefore it wouldn't be a function. So there's no such thing as a function with x-axis symmetry except what? There's one function in the world with x-axis symmetry. Yeah? Oh my gosh, you're so close. Y equals, no?
0.
Y equals 0. Is that, Tori, is that you? Well done. Y equals 0. So, yeah, y equals x. Y equals x looks like that, so it's not the same above and below. But y equals 0, what is that? That's the x-axis, right? So it's the same above and below. So anyway, that's the only function with x-axis symmetry. But an odd function does not have x-axis symmetry. An odd function has origin symmetry. And I'm going to show you what origin symmetry means in just a second. But an odd function has origin symmetry. So it's kind of nice that the O's go together. O for odd, O for origin. Okay, yeah. All right, so how do we test for an odd function? We have to, right the word show. We have to show that f of negative x equals negative f of x. Now, we already answered what kind of a function is y equals x squared. Okay, yeah, that's the shape of the graph, but as far as even or odd, it's even, right? Because it has y-axis symmetry. Now, y equals x squared is even by looking at it, but what if we had to prove it? If you have to prove it, the first thing you find is f of negative x. So you replace your x with a negative x. So we have, here, wait, let me write this out here. So we have f of negative x equals negative x squared. Hey, what is negative x squared the same as? X squared. Hey, but what is x squared the same as? It's f of x, right? So anyway, because, like, if you can show algebraically that f of negative x equals f of x, then your function is even. That's what we're going to be doing on the next screen. By the way, odd origin symmetry. The origin isn't a line. How can you have origin? How can you have symmetry over something that's not a line? It's a point. What do we do? So suppose I stuck a pin. Here, I'm going to draw a graph with origin symmetry so you can see it. This graph has origin symmetry. Or a point symmetry is called a rotational symmetry. And what that means is if I stick a point right here. Jesse, please stop talking. Okay? Stay with me. This is good stuff. All right? If I take a point and stick it right here and rotate the graph 180 degrees, if it lands on top of itself, then it has origin symmetry. So origin symmetry is a spinning symmetry. And what it means is you stick a point in the origin, you spin the graph around 180 degrees, not 360, because then everything would have origin symmetry, but 180, halfway around. If it lands on top of itself, then yes, it has origin symmetry. Right? So point symmetry is rotational. All right. So this first problem, I'm going to walk you through it. Then I'm going to make you do the next two. Then I'm going to teach you the shortcut. All right? So for the first one, if we have f of x equals x cubed minus 2x, and I want to determine if this is odd, even, or neither, the first thing you always do is you find f of negative x. Doesn't matter if you're checking for odd or even or neither. You always start with f of negative x. So what is f of negative x? You replace your x's with negative x's. Excuse that dot. I have a question. What is 2 cubed? It's 8. What is negative 2 cubed? It's negative 8, because it's negative 2 times negative 2 times negative 2, right? So if you take a number times itself an odd number of times, the negative number is going to stay negative, right? Would negative 2 cubed be the same thing as if we took 2 cubed and multiplied it by negative 1? Yes. And that works for any number, right? So, negative x cubed, we're going to rewrite that as negative x cubed. What's negative 2 times negative x? Plus 2x. Once you've found your f of negative x and you've simplified it a little bit, you look and you say, hey, is this the same as f of x? Is it? No, it's not. Could we factor a negative out of both of these terms? Okay, if I factor a negative out of the first term, what do I get? Good, and then minus 2x. Does this look like f of x? Yes, so this equals negative f of x. What you've just shown is f of negative x equals negative f of x, which means this function is what? It's odd. Because f of negative x equals negative f of x. I want you to take a minute and see if you can figure out odd, even, or neither for the next 2 examples. Odd, even, or neither. Too long. All right, so for this next one, so we f of negative x equals negative x cubed minus 2 times negative x squared. Negative x cubed is the same thing, we already said it earlier, as negative x cubed. But this negative x squared, when I square the negative x, what if it just becomes x squared, right? So here's the problem. This, does this equal our f of x? No. If I factor a negative out, what do we get? Right. Does that equal our f of x? No. So, oh, well, thank you. Oh, thank you. There we go. Okay. Now, does it equal our f of x? No. So, f of negative x doesn't equal f of x. It doesn't equal negative f of x. It doesn't equal anything. It's a neither. All right, last one. So we start with an f of negative x. So we get negative x squared minus 4. Hey, what's negative x squared the same as? X squared. Well, what is x squared minus 4? It's f of x, right? So you just proved that f of negative x equals f of x, which means this function is even. All right, would you like the shortcut? Okay, the shortcut only works for polynomials. Now, what's a polynomial? Okay, so for polynomials, a polynomial is a string of terms where you have like number times x to a power plus number times x to a power plus number times x to a power, that kind of a thing, right? So all 3 of these are polynomials. Polynomial, polynomial, polynomial. They're all polynomials. They're all numbers times x's to powers. Okay. Let's take a look at the exponents. What's the exponent on this term? 3. What about this term? 1. What are 3 and 1 both? What kind of numbers are they? They're both odd numbers. What's this one? 3. What's this one?
2.
Are they both odd?
No.
Are they both even?
No.
They don't match. Oh my goodness. What's this exponent? Okay, here's the question of the day. What's this exponent?
2.
If it was 1, there'd be an x there. How many x's have we got here? 0. This is -4 times x. You can think of it as times x to the 0. What's anything to the 0 power? 1, right? So this is -4 times x to the 0. What is 0 odd or even? No, it's not a yes. There's an answer.
Yeah.
It's even. 0 is even.
What?
0 is even because 0 is evenly divisible by 2. That's the definition of an even number. What's 0 divided by 2? 0.
Always 0.
Right?
Must be 2.
You can't. Okay. So, all right. So for polynomials only, if all exponents are odd, then f of x is odd. If all exponents are even, then f of x is even. If there is a mix of odd and even exponents, then f of x is neither. Oh my gosh, i.e. Why am I having a brain freeze? Did I spell that right? I-E-T-H-E-R? E-I-T-H-E-R?
No, N-E-R-T-H-E-R.
Oh my gosh. Yeah. Wow. Total brain freeze. Let's get that right. N-E-I. There we go. T-H-E-R. Okay, we're good. Okay, little side note. Constants are even. A constant is a number with no x next to it, right? Constant is a number with no x next to it. So constants are considered even. All right. Oh, and there's a bell. We're not done though. Okay. Shh. We're going to take 3 more minutes. The first thing we're going to do, just sit back and chillax for a second. So, if we're in Desmos, okay, this is the graph of x cubed minus 2x. Is x cubed minus 2x odd, even, or neither? Odd. It's odd because all of the exponents are odd. Take a look at this graph. If I stuck a pin in the origin and spun it around, would it land on top of itself? Yes, that's that rotational symmetry, right? Now, if I change this to 2x squared, it looks very similar, but remember, it has to be a pin around the origin. You can't just stick the pin anywhere you want. It has to be in the origin. So for this, if I stuck a pin in the origin and spun it, would it land on top of itself? No. Does it have y-axis symmetry? Is it the same on both sides of the y-axis? No. Then it's neither, right? If I made this like an x to the 4th minus 2x squared, first of all, just looking at the equation, odd, even, or neither? Even. Look at your graph. Does it have y-axis symmetry? Yes. Okay. So even functions have y-axis symmetry and all even exponents if they're polynomials. Odd functions have origin symmetry and all odd exponents if they're polynomials. Okay, and then neither are neither. All right, last topic of the day. Okay, yesterday we solved quadratic equations by taking the square root of both sides. Today we're going to solve square root equations by squaring both sides. So your steps for solving a square root equation: step 1, isolate the root. What does isolate mean? What does isolate mean? Get it alone. Get it by itself, right? Okay, and then square both sides. So, for this first one, is the square root isolated? Yes. So we're going to square both sides. What is the square root of x plus 3 squared? X plus 3. What is 5 squared? 25. So if I subtract 3 from both sides, what does x equal? 22. Let's check. I'm going to erase all this extra stuff here. If I plug a 22 in for x, I get 22 plus 3, which is 25. What's the square root of 25? It's 5. Yay! All right. For this one, you know what? I'm going to make you guys do it. Take a minute. Solve it. Start to finish. What do I have to do first?
Subtract 25.
Subtract 25. So I have negative, don't lose that negative, root x minus 2, 17 minus 25, negative 8. What do I do next?
Divide by negative.
Divide by negative. Could I multiply by negative? Yeah. Yes, it's the same thing. All right. So square root of x minus 2 equals 8. Now what do I do?
Square both sides.
Square both sides. This, whoa. Ah! I don't know what that. How did it separate into 15 letters? Okay. All right. So I square both sides. What is square root of x minus 2 squared?
X minus 2.
What is 8 squared? What's the last thing I have to do? Add 2. 66.
Wow.
Hey, check your answer. Check your answer. 66. What is 66 minus 2? 64. What's the square root of 64? 8. What's 25 minus 8? 17. We got it, right? Okay. And here endeth the lesson. Okay.